Let's begin our discussion of object-oriented programming with classes. A class defines the abstract characteristics of a thing or an object, including the thing's characteristics, its attributes, fields, or properties. And it also describes the thing's behaviors, the things that it can do, the methods, or its features. Classes provide modularity and structure in an object-oriented computer program. A class should typically be recognized to a non-programmer familiar with a specific problem domain, meaning that the characteristics of a class should make sense to a non-programmer in context. The code for the class should be relatively self-contained. Collectively, the properties and methods defined by a class are called members. So, in creating an object-oriented design, you identify groups of objects, such as customers or accounts in my banking example, that have identical attributes and behaviors. These groups are called classes. You define the properties or data and behaviors, that's the procedure code, for each class. When implemented the object-oriented application, you write code that defines each class. The code contains data to represent the attributes and has procedures. Those are called methods. And that implements behaviors. When you execute an application, the class definitions are used to create object instances. At the center of object-oriented programming are, well, objects. Objects model real-life objects or things, as we said before, with their various attributes and behaviors. In software terms, objects are combinations of data and procedural code. Objects must be instantiated, and they have methods and data. They also may have properties and attributes. So, for example, let's go back to my banking sample here. A bank has customers. Customers have names, addresses, and bank accounts. They deposit money in and withdraw money out of their bank accounts. An object-oriented view would have customer objects and account objects. Customer objects would have name and address attributes. Account objects would have balance and possibly previous transaction attributes. So, as you can see, I'm describing properties, attributes, and data associated with customers and account objects. The procedures associated with each class are called methods. Methods can be thought of as modules or subroutines. A class may have as many methods as it requires in order to manage its data. Methods also have different types of visibility. Private protected means that a method is only visible within that specific class. The data for that specific method is also visible to that specific class. Public methods are exposed for all other applications. Methods are identified by their name, the number and formats of their parameters, and to the class that they belong to. You can use the same name for methods in different classes, and you can also define methods with a given class using the same name, but you can also distinguish them by the number and format of their parameters. When you invoke a method, the system figures out which method that you want by matching the number and format of the parameters you provide with the number and format of the parameters in the different definitions. The combination of method name, number, and format of the parameters is often referred to as the method's signature. To invoke a method, you identify the object that contains the method, supply the method name, and pass any parameters required by the method. In COBOL, how we do this is we use the invoke statement to execute the code contained in the method. Okay, hang in there with me. All of this is about to make some sense. Now, encapsulation is the word generally used in object-oriented design to describe information hiding. The data for a given object can only be accessed and updated by the methods for that object. In other words, other programs or methods belonging to other objects can only access an object's data by invoking the appropriate methods belonging to that object. So again, there is a relationship between an object, a method, and of course its data. Another way of looking at this is that the encapsulation conceals all of the functional details of a class from objects that send messages to it. Encapsulation is achieved by specifying which classes may use the members of a given object. The result is that each object exposes to any class a certain interface, that is to say, these members that are accessible to that class. The reason for this encapsulation is to prevent clients of another interface from depending on those parts of the implementation that are likely to change in the future, thereby allowing those changes to be made more easily, that is, without changes to given clients. Now, let me give you another banking example. An interface can ensure that money can only be added to an object of the class account by code in that specific class. Okay, let's put this all together, shall we? A class defines or instantiates an object. An object contains one or more methods that can be public or private and protected, and can be invoked, or in COBOL parlance, called. Data is encapsulated or owned by a given class or object. Data can also be defined as or designated as public or private and protected, and is only accessible by invoking or calling a method that is associated with its owning class.